Well, good morning and welcome to today's FS Club webinar. And we're delighted to have as our guest Dr. Nichola Conlon. Nichola is dialing in from Newcastle, and yet Nichola and I had the had the pleasure of meeting, of all places, in Saudi, in Riyadh, where she was presenting on the science of aging well at what is frequently called Davos in the desert, the FII conference there. And I was so intrigued, I asked Nichola to present to us today. What is the science of aging well, and is it just snake oil or not? And as you can imagine, she has some robust and very, very well-informed views on the topic. Now, you know me, I'm Michael Mainelli. I'm one of the directors of Zien, and it really is a privilege to be able to introduce these wide-ranging and interesting lecture series and to meet so many fascinating and distinguished and intelligent guests, which is fun. But we can only do all of that fun thanks to our sponsors who you see right here before you. And we thank them all most warmly for letting us range widely and freely across technology, economics, and finance. And today's session may sound a little bit sciencey about aging well, but we will and have in the past also looked at the economic impact of this. We can possibly touch on some of that in the question and answers. Now, for those of you who know our series, you'll be familiar with the format, which is that my job is to get out of the way as quickly as possible and let you hear from our expert, Nichola. Nichola will be speaking for about 20 minutes, and then we have 20 minutes for questions and answers, where we rely very much on you contributing. So 3 points of order. Firstly, Nichola's slides will be posted and available afterwards. Yes, this is being recorded, and the recording will be available in about 2 working days, so approximately midday on Thursday. And I would encourage all of, sorry, I'm saying midday on Wednesday, and I would encourage all of you to ask your questions through the GoToWebinar question and answer facility, principally because I am not on email or WeChat or anything else. I'm here with you and with Nichola, and all your questions and comments will be sent to Nichola, even if we don't get time for them, with your email attached so that she can respond to you if she wishes. But when you type your comments and questions in, please do so early if you can, so that we can organize them and get them in time for Nichola to respond. Anyway, I believe that's all the housekeeping that we need, and I would like to therefore hand over to today's speaker, Dr. Nichola Conlon, who has founded Nuchido Laboratories. Nichola, the floor is yours.
Fantastic. Thank you so much, Michael, for inviting me to speak. Yep, we had a taxi ride in Riyadh together and got chatting. So thank you for inviting me to come and speak a bit further. So first of all, I'm actually going to start by making a little bit of a statement. Which is probably a controversial statement to many, but that's within our lifetimes, we will take drugs that will slow aging. And I know already a lot of people will be thinking, oh my goodness, you know, what a thing to say. You know, what would make me say that? Because it's probably something that people have never even considered. But that is actually my job. So I've spent 9 years in drug development, working on developing drugs, supplements, and topicals that are designed to do exactly that. They are designed to slow aging at the cellular level. And I'm a scientist. I'm actually an expert in cellular aging, which basically means looking at what is actually going on within our bodies, so inside our cells, to cause all of the signs and symptoms that we experience as we get older. So it's really what's going on beneath the surface to cause aging. Now, I know straight away what a lot of people are going to be thinking. They're going to go, okay, this is snake oil. You know, there's no secret that the anti-aging space has a very bad name for itself. For years and years, as far as people can remember, you know, we've had salesmen saying, oh, take this elixir and it'll make you younger. Or we've had anti-aging skincare companies saying, you know, this cream will reverse your facial age or whatever. It's got a bad reputation. And to be fair, even within my industry as a scientist focusing on aging, for a long time, many scientists in my field believed that aging was something that was inevitable. There was something that you couldn't reverse, and there was no way of actually doing this. But now the science that we've seen coming through within the last 10 years has completely changed this perception, to the point where you would not find a single scientist within my field who would argue that aging is not reversible. So without further ado, I think the first thing we need to talk about is aging, because what actually is it? Because it's a word that we are all familiar with, we've all heard it. But if I was to ask people, what is aging? Like, why does it happen? How would you describe the process of aging? They'll tend to talk a lot about the symptoms or the things we experience and how we look and feel. But if I dig a bit deeper and say, but what is it? Like, what's going on to cause it? That's when people get a little bit stuck, and they'll go, oh, it's just this natural process. It's something that just happens. It's inevitable. It's part of life. They're the types of answers that you tend to get. But this doesn't really help us to explain what it actually is or what's going on to cause it. So in order to explain that, we need to do a little bit of a science lesson. And I appreciate that you guys aren't a bunch of scientists, so we're not going to do anything crazy, but we need to really understand what's going on scientifically to actually cause aging. So the first thing to highlight is that, unfortunately, for anybody that thought, their life purpose was to become an entrepreneur or a scientist or whatever that may be, it's actually not. Our life purpose as humans is actually to pass on our DNA, at least as far as evolution is concerned anyway. Our bodies are basically designed as a bit of a vessel to carry our DNA, to make sure that our DNA actually goes through reproduction and is passed on to the next generation. So everything about our bodies has been designed to actually fulfill this purpose. And this means our bodies have become very good at trying to protect this critical DNA. But life is actually very destructive. So we know that everything is trying to damage us constantly. We've got everything from not only our diet and lifestyle, but also just the simple process of living. Our metabolism, our cells generating energy are constantly causing damage to our bodies that our bodies have to fix. And just to put this into perspective, it's estimated that every day in every cell, we're getting around 10,000 pieces of DNA damage that our bodies are literally repairing behind the scenes without us even knowing about it. So that's how good we are at repairing this damage. But the problem is, although evolution has made us very good at repairing this damage, it actually costs the body a lot of energy to do it. It's not simple to do. And this means that when we're young, the body kind of goes, okay, we've got to get to childbearing age, we've got to get the DNA across to the next generation in one piece. So it's actually worth investing all of this energy. However, as we get older and we're past childbearing age, the body's kind of like, okay, should have fulfilled the purpose by now, and actually, is it worth investing all this energy to protect a body that should have done its job? And this is called a very famous theory of aging, which is the disposable soma theory. And basically your soma, your body, essentially says that it's disposable. It's just like this vessel to do its job, protect the DNA, and then that's it. Which sounds a bit grim, but scientifically, that's exactly what it is. And what does this mean for aging? Well, just look at this life expectancy graph. So back in the 1800s on the left, you'll see that we were very lucky to actually make it to our, past our mid-40s, so just after childbearing age. However, over the last 200 years, if you fast forward to now, we're looking at a life expectancy of, well into our 80s. And this has happened very, very quickly due to advancements in sanitation, healthcare, things like that. So essentially what it means is that we have all of a sudden are living these very long lifespans, and we're not designed to do that. We were designed to be dying back in our 40s, and quite frankly, living to our 80s is very new territory for our bodies. So when I get people to think about aging, what I often get people to think, the way to make it make sense is to think of the fact that our bodies have been very good, have evolved to be very good at being young, but we have not evolved to be good at being old. Because if you think about it, why would our bodies evolve to be good at something that we were never ever likely to achieve? We were never ever going to live till our 80s. And unfortunately, evolution takes a lot of time to catch up. And this is a problem for us modern humans, because what it means is that our lifespans are now longer than our health spans. So our lifespan is simply the number of years you will live. You know, everyone's heard of that, but health span is a bit more of a new term. And that is the actual number of years you will live in good health. So it's the proportion of your life that you will be healthy. And when I mean healthy, I mean not suffering from frailty, not suffering from age-related diseases, being able to live a happy, independent, and fulfilled life because you are healthy. And just to put that into some figures, so if we're looking at a female, her average life expectancy in the UK right now is 83 years. However, her health span is only expected to be 64 years. So this means at current rates of health, it's expected that this person would live 19 years, so that's nearly 23% of her life in poor health. And that means suffering from chronic age-related diseases. So that's not good stats, but I'm sure if many of you have older parents, you'll understand that this really is the reality that we're facing right now. And the reason for this is because aging is actually our biggest risk factor for all the major diseases we suffer. I always say that putting on years is probably one of the worst things you can actually do to your health. And the reason for this is, if you look at these graphs here on the right, your incidence of diseases, chronic diseases like cardiovascular disease, dementia, cancer, you know, they all whoosh straight up after age about 40, 50. So, you know, these aren't great stats to be looking at, but it is the reality. But, you know, everyone says, well, aging's inevitable, we better just accept it. You know, we accept that we have this life trajectory, that is, we're born, we learn, we earn, then we retire, and then we expire and think, you know, it's a bit downhill after that. But what happens actually if you could slow, stop, or really actually reverse aging? Would this change things? Would this mean that we could actually live our longer lifespans that we now have due to improvements in healthcare and sanitation, but in good health? So could we actually get health span to be a bit longer? And this is exactly what scientists began to say. They said, you know, let's look at how we're treating aging at the moment. On the left here, you'll see we've got all of these age-related diseases. We're basically researching all these individual diseases one by one, and then we're treating all the individual diseases one by one also. We're treating them as very separate entities. And quite frankly, this isn't really working. We've got a huge issue where people are spending nearly a quarter of their lives in poor health. It's a huge economic burden, and it means that people quite, you know, to put it bluntly, are having not a very nice end of their lives. So, you know, is there something we could be doing differently? Because this is something that is only going to get worse. Because by 2030, 1 in 5 people in the UK will be age 65 and over. And also, we now know that the fastest growing segment of the population is actually the 85+ year group. So this is something that is only going to be getting worse. So the other way to think about it, scientists said, okay, so if we've got all of these different age-related diseases, and we know that the biggest risk factor for them is in fact aging, then technically aren't these like symptoms of aging? And if these are symptoms of aging, then actually is aging not the disease? And actually, should we be targeting the root cause or the main reason that's causing all of these things and actually looking at treating aging? Because if we could slow aging by acting at this level, would it mean that we could hit all of these diseases in one go? Would it mean that we could reduce the onset of age-related disease and, most importantly, improve health span? So this was a very different way of thinking about things. Now, for a lot, this was probably about 10, 15 years ago, all this research started. And I have to say that at the start, when scientists were writing grants saying that they were going to treat aging and they were going to classify aging as a disease, a lot of them were laughed at. And, they said it's impossible. But now, as I mentioned earlier, there's not a single scientist that would argue against this, because what we have found is that actually you can slow aging and it can also be reversed. And the most amazing thing is that the effect that it has on health span. So just by slowing cellular aging just a little bit, you can have a major impact on multiple age-related diseases in one go and improve health. So I hope from that quote at the start where I'm saying, we're going to take drugs to slow our rate of aging, I hope some people now maybe have their mind open to it a little bit more and it doesn't seem so crazy now I've explained it. It's a hugely exciting time to be involved in aging research. You'll have probably started to see a lot of headlines come out in popular press now where people are talking about this a lot more. And there's a huge amount of investment and research being put into it now. So it's all incredibly exciting. Now, I've been asked to ask a couple of questions to make sure you're all paying attention. So the first question I'm going to ask, I think there's going to be a poll that's going to pop up, is by 2030, how many people in the UK will be age 65 and over? And there's a couple of options there. Is it 1 in 5? Is it 1 in 10? Or is it 1 in 20? I'll just give you
one of the things about this crowd, Nichola, is they're very, very opinionated and know their minds. And also, I think they're very, very right. So we're just going to close that poll and present the results. Virtually everybody answered, and overwhelmingly 80%, 1 in 5. Put us out of our misery. Were we right or wrong?
Yeah, that is right. 1 in 5. And what that shows us is that this is a huge issue, but it's also a huge opportunity, to be able to harness this research and actually use it to help people. So the next question is, what is your biggest risk factor for cancer and heart disease? Is it smoking, unhealthy diet, or your age? I'm hoping everyone gets this right now.
And again, they're moving very, very fast. And there we go. And we're presenting those results. The vast majority believe it's our age, but is that right?
It absolutely is. Really what I should have done is put that at the start and see what people answered, because I'd be willing to bet that a lot of people probably would have put smoking. And we know that both smoking and an unhealthy diet are also bad, but actually age is actually the worst. But the reason we don't hear much about it is because a long time people didn't think there was anything you could do about it. So, it was never mentioned as an option to try and change. So, that's the reason why. So moving on. So the key question is, well, how on earth do you actually slow aging? The million-dollar question, what do you actually do? So what's been found is within our cells, there are actually 12 key things that become dysfunctional with age that cause aging. And scientists have agreed on these 12 different things and have very strong evidence. But I'm just going to focus on one today. And the one that I've chosen to focus on is for 3 reasons. The first is that there's very strong evidence to support it. There are hundreds, if not thousands, of papers demonstrating its effects. The second thing is it's simple. You don't need to be doing any crazy operations or gene therapies or anything like that. And the third is that it's actually something that's available now. And that something is a molecule called NAD or NAD+, and it stands for nicotinamide adenine dinucleotide. And don't worry, I'm not going to test you on that before everyone quickly writes it down. But the question I always get is, what does it stand for? And it's a long name, so that's why everyone always abbreviates it to NAD or NAD+. You'll commonly seen it referred to as. And it's, I like to call it probably one of the most important molecules you've never heard of. And that's because we know that if you didn't have any NAD in your cells, you would literally be dead in 30 seconds, because it's so incredibly important for many, many reactions in your cells. But the 2 things, if you're going to remember anything that it's most important for, are firstly cellular energy production. So it helps convert the food you eat into the energy that all all your cells need to perform. And the second thing it's important for is cellular repair. And remember from the start, we need good cellular repair to be constantly working in the background, but it gets turned down as we get older. Now, when it comes to NAD, if we, as a general rule of thumb, if we have high NAD levels, we have high levels of energy produced, and we also have high levels of repair. If we've got low NAD, it means energy production gets turned down and also repair gets turned down. Now, the reason why NAD is so beneficial at activating a lot of repair processes is it actually works in tandem with a set of proteins or genes called longevity genes. And these are basically things that switch on many pathways that are associated with cellular health. And we know that when we're younger, these pathways are firing, making sure that things are getting repaired and recycled and kept in good condition, but they seem to get turned down as we get older. And the key link is that these sirtuins, these longevity pathways, absolutely need NAD to function. Without NAD, they can't do their job. Now, the reason NAD is linked to aging is because, like many other things, it's been found to decline as we get older. And this decline is actually quite substantial. It's estimated that our NAD levels halve every 20 years, and this is from birth. So even from by age 20, we've lost half the NAD that we had when we were born. By age 40, this is halved again, and so on, to the point where we're at more advanced stages, we really don't have much NAD left in our cells at all. And this is a problem because it means that energy production gets turned down, which is why we don't have as much energy as we get older, and also repair gets turned down, meaning we get damage in our cells, and this ultimately manifests as the signs and symptoms of aging. So scientists said, okay, you've got this really important molecule, NAD, it declines with age. It means it can't do its important functions in repair and energy production. So what happens if we just don't let it decline? What happens if we keep it topped up or we restore it back to youthful levels? Would that actually keep repair and energy production switched on so you didn't get some of these issues that are associated with aging? And basically what was found was that, first of all, it was pretty simple to boost NAD, and secondly, that by boosting it, it could have a huge variety of benefits across the whole body. And this is because it's found in every cell, so its decline and also its boosting has a benefit across the whole body. And you can see here a lot of the benefits are all to do with health span, everything from cognitive function to cardiovascular function, muscle, things like that. All of these things were improved by boosting cellular NAD levels. So back in 2017, I left my job in drug development, and the reason I did that was because actually what was found is that you can boost NAD without drugs. So a lot of molecules that are actually regulated as supplement molecules and safer supplements, you can actually use to boost NAD levels. So you don't need expensive or complicated drugs to do this. You've got to remember the body doesn't know the difference between a drug and a supplement. They're actually both powerful physiologically when it comes to the body. So what I did was I founded Nuchido Laboratories, and I wanted to translate all the science from these breakthroughs, but into consumer products that people could be benefiting from now. And I designed this supplement that was basically designed to restore your cellular NAD levels by increasing cellular production and recycling of NAD. Because what we now know is that your body is actually very good at producing NAD. It just gets turned down as you get older, but you can actually reactivate this. Now, because of my background and because of the bad rap that supplements get, I wanted to do a clinical trial to prove that it actually works. So we did a 24-person double-blinded placebo-controlled crossover study. Many people don't realize that supplements aren't legally required to have any studies. So, all the things you see on Boots, most of them don't have any clinical studies, but this is a gold standard clinical trial that we performed on it. And I won't bore you with all the graphs, but what we did find was that the supplement actually boosts NAD levels significantly in our cells, so it's restoring that important molecule. It switches on those important longevity pathways. It also reduced inflammation, and we know that inflammation is a leading cause of aging. And also it reduced something called glycation, which if anyone's got any questions on, I can go into a bit more, but that is basically something else that's shown to lead to cellular aging. But just to finish, so my last slide, I just want to show you this, because what we did measure was, does the supplement actually reverse aging? And the way that we measured this is we looked at something called biological age. So people actually have two ages. You have your chronological age, which is just simply the number of years you've lived, but you also have your biological age, which is the rate at which you are aging on the inside. And that's the most important one, because that is the one that links to health. And you can measure this in the lab. You can take people's cells and measure their biological age. And we found that in 28 days of supplementation, we actually reversed biological age by 1.26 years. So this is literally showing that you are improving and reversing the biological age of the cells inside. So I'm going to leave it there. There's a discount code there. If we could provide one, so there it is. If you're interested, there's our website. There's different ways that you can contact me, and I'm happy to do the questions, and I'm excited for them.
Wow, well, that was great, Nichola. We do have a lot of questions. They're going to have to be quite short and sharp, I think. I'll start with just a couple of factual bits. Trevor Hilder wonders whether or not the answer to your first question, and others, that he will be taking drugs to prevent aging. Will he do that when he's already 72 today? So that's a quick one. But Trevor was also curious. Surely on your numbers, there have always been some people who've lived into their 80s or 90s, maybe not many, but some. And he's also curious, you gave the health spans versus lifespan data for women, but what about men? So will he be taking them if he's over 72? What about women and men? And people were surely, the maximum age was still achievable.
Yeah, okay. So age 72, I'm estimating that within the next 20 years, there'll be, that's the best chance of having these types of drugs. Having said that, if this is something that, you want to start looking at, there are already drugs out there that are available that, people take off label. That are known to work very well. So I think, although I say people will take drugs within our lifetimes, some people already are, and there's some big trials going on in the US looking at particular drugs to do this now. So it's already started. So I think there's a good chance. The second one is that some people just naturally live longer than others. So yeah, back in the 1800s, there will have been people that actually live longer than age 40, 45. We know that some people have better genes. So it's estimated that 80% is your lifestyle and 20% is actually your genes. So we know that some people, I mentioned the sirtuins and the longevity pathways, have particular gene variations that just make them live longer. And that's just part of being human. There's no average human. There's always outliers. The third question, when it comes to health span, I can't remember off the top of my head, but I know usually males have a bit of a worse outlook, actually. I know their life expectancy is shorter. The reason I put that stat in is it's actually, so I have a little girl. She's not so little, she's 13 now, but she was born in 2009. So I usually say, oh, for my daughter, this is her life expectancy and what she's expected to have as a health span. So that's why I usually use that example.
Okay. You touched on strong genes. Bob McDowell made a comment that I come from a family with strong genes. By way of example, my grandmother came from a Victorian family of 12. 10 lived till they were over 80, and she lived healthily until she was 101. So, Bob, I think you've got that 80-20 rule there. We had a question here from Bob as well, though. To what extent does a strong and active intellect contribute to positive and slower aging?
So your brain and your cognition and your cognitive function is, you almost think of your brain as like a muscle, a bit like your physical muscles, and that the more you use it, the famous saying, use it or lose it. If you're using your brain and being active and using your brain, the studies do show that it's, you're more likely to suffer from less cognitive decline, or indeed push that date back of when it starts to happen. And yeah, so I think The other thing is to kind of probably mention is, you know, the socioeconomic kind of link with that as well. And, you know, generally if people have a higher intellect, they're more likely to go out and do the research and actually, you know, come to webinars like this and, you know, understand and learn that there are things that could be doing to protect the health span. So yeah, I guess there was an interesting study done in where I live in Newcastle, and we have it's called the Metro, a train line that goes through Newcastle, and they basically looked at life expectancy along the different stops. And obviously, as you went out to more affluent areas in the suburbs, the life expectancy was much greater than the more inner city areas. So there is a big disparity there.
Okay. Graham Elliott points out that Cassiodorus lived about 100 years in the 5th and 6th centuries. Thank you for that one. And I've got a question, we've got a lot of questions about NAD, but before we move on to that, I just wanted to tackle a couple broader ones. Given that men are often capable of reproducing into old age, Mark Henderson is curious, if life is about passing on DNA, why do men age faster?
So there's a lot of different theories about this, but what we tend to see is men seem to accumulate more damage. So a lot of the, you know, when I mentioned biological age at the end, we know that biological age and people that have a higher biological age basically seem to have had their repair switched off earlier or have accumulated damage faster. You know, there's theories that this could be due with different hormones and things like that. It could be due with, you know, males generally being slightly more reckless than females. That is, you know, a real thing due to testosterone and things like that. So there's not a clear-cut answer. You know, the discrepancy in life expectancy and health span between men and women is not just in humans, it's also in lots of different species. So, you know, a key theory is all about the hormones and things like that affecting it.
Okay, we've got a couple of questions about diet. Deepak Merchandani would like to know, does going on a vegetarian or vegan diet help in any way? We also have a question from Thomas Brooks. I read that eating 90% chocolate is proven to increase health span. Any comments on that? Yeah, let's start with those two. Oh, and
Okay.
sorry, and the third one, Dan Finney, does intermittent fasting help reduce adverse aging effects?
Yeah, well, I'll answer the first question with the last question because actually what I was going to say is what seems to be interesting when it comes to aging and diet is not necessarily the composition of the diet, i.e. yes, it should be healthy, etc., but it shouldn't be just vegan or just meat. It seems to be when and the frequency of eating that is linked to longevity. So it's found that in diets where you're actually restricting the times that you eat, so calorie restriction or intermittent fasting, where you may go for like 16 hours not eating and then only eat within an 8-hour window, what's found is that that does improve health span and it increases longevity. And actually, if you think about it, it makes perfect sense because we have evolved to not be eating all the time, but our modern lives were promoted to have our breakfast, have our lunch, have a snack. You know, there's a constant availability of food. So what's found is if we're constantly eating all the time, it means that our bodies get a bit lazy and they've got all these repair pathways, but because there's just a constant influx of food coming in all the time, it's like, oh, it doesn't matter, you know, we don't need to repair because we've got nutrients freely available, we can just keep building new things. But when you fast, actually what happens is our body goes, oh, you know, there's not new nutrients come in, we've got a bit of energy stress. So actually we need to book our ideas up and switch on some of these cellular repair pathways and start recycling and reusing things and, you know, making sure that we're fixing what we've got because we don't know when the next meal's coming. But in our modern lives, these pathways simply aren't activated. So fasting actually switches them back on. When it comes to vegetarian, the current sort of thinking is that no, vegan is not a way to, you know, extend lifespan. But what is shown to reverse aging and reduce biological age is having a diverse diet that includes 30 different plants each week. So that could be like nuts, seeds, veg, herbs, anything, but having that good variety has been proven in a clinical study to reverse biological age.
So I have to give up on my pot noodles, I can see.
Or add some veg.
Uh, now, just a couple more things there. You've spoken at length about you know the way in which this approach has been going, but we have a question here from Maury. Sorry, not from Maury. We'll come on to Maury Shank's question in a minute. I'm losing it here in the charts. We're off the charts here on questions, and it had to do with yes, Mark Henderson is curious. I don't think you've established the difference between causality and coincidence. Does aging cause cancer, or does it coincide with it?
What causes cancer is a reduction in the repair capacities. Cancer generally happens when we get too much DNA damage in a cell, and then there becomes an issue with replication. Now, obviously, some young people get cancer. So sometimes there's just an issue that happens, it's spontaneous, it's kind of like bad luck, but the general consensus is that our age is our biggest risk factor for causing cancer because repair gets turned down.
Okay. Mark Cook was just curious. I thought the shortening of telomeres was the main trigger for cellular aging.
So that is one of the, so you remember I said there was 12 different causes. Telomere attrition is one of them. And that's, one of the kind of first things that was looked at. It's now known that that's kind of an old way of thinking and that there isn't just one cause of aging. It's really many different things going wrong, namely these 12 things. But yeah, telomeres, for anyone that don't know, are the caps on the end of your DNA. People compare them to the little plastic bits on the end of your shoelaces, and they basically stop your DNA from unwinding. And as you get older, the caps get shorter and shorter, then the DNA frays, and that causes things like cancer. So that's what telomeres are.
Great. And just before we dive into quite a few questions about NAD, Graham Kennedy and Nick Bertels are curious. What are the you don't have to name all 11, but can you give a sample of the other 11 areas from the 12 that you mentioned?
Yeah, so a key one is inflammation. Everyone's heard of inflammation. We know that it's really good when we're young for basically, preventing disease and things like that. But as we get older, we suffer chronic low-grade inflammation across our body, and that's almost burning away like a bit of a smouldering fire, causing all sorts of issues. Another one is something called cellular senescence. Basically, you may have heard in some newspapers recently people talking about zombie cells when it comes to aging, and these are basically cells that have become so damaged that rather than the body getting rid of them, they just sort of put them to sleep, and they start to take up room in our tissues. But what's been known is that actually they're not sitting quietly, they actually start spewing out a lot of inflammation, which then contributes to inflammation that causes aging. And it's been shown that if you can remove some of these senescent cells, these zombie cells, you can actually reverse aging, and that's another really exciting area.
Now, just a little bit of flavor. Well, we'll dive in if we can onto NAD and this. So, question from Jenny Wardle: how can you get NAD naturally? Which foods help?
So the best way to actually get NAD is not from a food, not from your diet. The best way is to activate your own cells to make it. Cells are very good at making it. Two of the best ways are firstly, any exercise. So anything that causes a bit of energy stress, so you'll know when I was speaking earlier about fasting, it triggers the cells to go, oh my goodness, there's like an energy stress, we need to produce more energy. So what it does is it switches on the enzyme that makes NAD. So exercise switches on this enzyme, particularly high intensity interval training has been shown to do it, and also fasting. So intermittent fasting, as I discussed earlier, that's another way that's been shown to naturally switch on your own NAD production pathways.
Well, that's good, because we had a few questions from Clive Bullen and from Mark Henderson about exercise. So I think you've touched on that. We'll all we have time for there. John Knights, what are the active ingredients in the supplement?
So there's multiple different active ingredients. I think the first thing that people notice is it doesn't include NAD, and they go, oh, why has it not got NAD in it? The reason for that is because NAD, it's firstly a very big molecule, which means it struggles to get through the gut and get into the cells where it's needed. And also it's very unstable. So if people are, which you will see on Amazon, people putting NAD in pills, it will not be NAD because it'll be all broken down and degraded. What our product contains is a combination of different ingredients that actually switch back on that pathway that I've just spoke about. So that key enzyme that makes NAD, we know the main reason that NAD levels decline is because this enzyme declines. So all the ingredients in our formulation are designed to switch back on that enzyme. If anyone wants to look at the ingredients, they can go to our website and we'll go through every single ingredient one by one and explain exactly why it's in the formulation.
Okay. Now, Jane Phelan is curious about what are the results for your Time Plus supplement over a longer time frame, say 1 year to 3 years. And I'm wondering if you've got the data for it. But Graham Kennedy has a slightly more open question. Your study showed that Time Plus reduced biological age by 1.26 years after taking it for 28 days. Do you have any feel for what the maximum age reduction one might expect from taking it longer? And actually a question from a lot of people, how long do you have to take it? Is this a permanent thing?
Yeah, so we're going to be doing some longer studies. I think one thing to point out is these are, to do a clinical trial, it's very expensive. So people say, well, why only 24 people? Why only 28 days? Well, it's an expensive thing to do for a company that isn't legally required to do it. So, we're doing it just for the scientific credibility. But we are doing some longer studies, so they will be coming. What was the other question?
Is this something one would have to take for the rest of your life?
Oh, yeah. So we always say things like NAD, it's looking at investing in your cellular health. We know that in everybody and even every species, NAD declines with age. And we know that it's incredibly important. So I always say when it comes to things like supplementation, we know it's something that benefits everyone. And yes, it is something that you'd want to be taking on a continual basis to make sure that you're keeping your NAD levels topped up. The other question was about the biological age. So we are going to be doing a longer study on that, but we do know from some people that had actually done biological age, have tested it since the trial finished. So the trial actually finished just before COVID, but because of all the COVID restrictions and stuff, the samples couldn't be analysed. We've had people that were on the trial do another biological age test, and some of them have gone lost up to 5 years of biological age.
Okay. Well, we had Mark Henderson about whether or not you were doing blind testing. We had Hugh Purser as well, and Peter Cousins about your subject. So I think, Dr. Conlon, you've really recovered that.
Yeah, and on our website as well, I've done a whole webinar if anyone's interested, all about the study with all the results, and I go through all the ingredients and everything.
All right, well, we'll get that posted on this site so that people can link out to it. Maury Shank, David Sinclair at Harvard has suggested that taking NMN as an NAD plus precursor is advisable. What do you think of his research, and how does your supplement stack up to NMN?
So NMN is what we call a precursor to NAD, as you mentioned. It's basically like one of the building blocks that the body uses to make NAD. And the reason that this came out several years ago is because people realized that NAD itself is too big and unstable to take. So they thought, okay, the next best thing is let's give the body the raw material that it needs to make NAD. And that does boost NAD levels, but all the new science that has since come out now shows that the reason that NAD declines is because the enzyme that takes these precursor building blocks and sticks them together to make the NAD declines with age. Therefore, you can take as much of the raw material as you want, but if you don't have that enzyme, then it's not actually going to be making it into NAD. So that's how our product's different. It actually reactivates that enzyme. So it also does have a precursor in, but also all the other ingredients that actually activate the enzyme.
All right. I think you've hammered snake oil quite a bit. A great question from Trevor Hilder that I should have asked myself. Do you take it yourself?
I do, yes. I'm the longest standing person. I've took it since we very first discovered it. So,
And how old are you?
so
73,
I'm
74?
I'm 36 chronologically, but my biological age is 20.
Okay. And I think this has been absolutely fascinating. I think an eye opener to us. There are loads and loads of extra questions here, but we unfortunately really don't have time for them. They will all be sent to you, so don't worry. You can email people as they come back. A couple that wish we'd had more time to talk about the impact economically. Looking at, is this going to lead to a population explosion? Is another question that's come up. So I think there's really, if anything, there's a great appetite, if not for your supplement, for talking about it. So perhaps we ought to come back on that at some point in the future. Be really good to have you back. And I must say, Dan Feeney, it leaves me wondering too. We haven't had anything here on so the micro hallucinogens, of LSD and psilocybin and all, and what those might do for brain health as well. So there's a lot going on out there, and I think it is, as you said at the very beginning, Nichola, a really exciting area and one that I think we can. I think many of us have kind of hidden from it over the years. We didn't want to confront those stark numbers. We don't want to talk about it, but now we can, because possibly there's hope that something could be done rather than just sort of putting our head in the sand. Right. Well, I have three quick rounds of thanks to give. Firstly, to all of our sponsors. Secondly, may I thank all of you today. I think this has been possibly one of the most vibrant ones ever. Rarely do we find ourselves unable to get through most of the questions, and today there's a whole stack of them, but I get to leave those to Nichola to fill in. But you can see here the webinars that are coming up, and I would welcome all of you joining us, not least on Mauritius as a FinTech hub tomorrow, but all of you, as ever, please do go to the website. We are also looking for speakers on the 27th of April for our Future of Green Hydrogen. That's a breakfast meeting next Thursday. Should be exciting. We've got a couple of Chinese people dialing in to present, but we would like to have some people from Europe or America also presenting. And finally, my sincere thanks to you, Nichola. A crazy taxi ride where I too was skeptical that you were some kind of snake oil saleswoman, and I came away convinced there was more to it than I thought, and I can tell from the reactions today that so has our audience. So thank you so very much for coming on. Unfortunately, we do not have advanced technology for applause, so one of the traditions here on FS Club is that we have our Korean karmic clapper, which is our high-tech version of the applause that all of the audience would have said, and many of the thanks and fascinating comments that are coming through now, and those will all be handed over to you as well. Thank you so much.
Brilliant. My pleasure. Thank you very much, everyone.